Next we have a different type of projection that is called as isometric projection. Isometric projection is a subclassification of axonometric projection. What is axonometric projection? Axonometric projection is nothing but the axis of the solid is going to be rotated at a defined angle with respect to the HP and VP. Now here we have three subclassifications of axonometric projections, namely isometric projection, dimetric projection and trimetric projection. In case of isometric projection, all the values will be reduced to equal length. That is nothing but each and every edges of a cube will be reduced for equal length. Now you can see whatever the edges you are going to measure, it is going to give us the equal value, that is 81.64 millimeter. But in case of 100 mm cube, which is going to be reduced for a diametric projection, you can see the two edges will be reduced for equal length and another edge will be reduced for a different length. That is called as diametric projection. And in case of a trimetric projection, 100 mm cube is going to be reduced unequally in all the three directions. Now you can see in one direction it is reducing 64 and in other direction it is 92 and another direction it is 85. Like this, we have three types of projections in case of axonometry. As I told you, isometric projection is a type of projection where all the edges will be equally reduced with respect to some value. How much it will be reduced? Now you can see cube is having the 6 square faces, but if you are going to see this cube faces, here we can see 3 faces at a time. In these 3 faces are supposed to be a square faces, but if you observe carefully, it will not be a square, it is going to look like a rhombus. If I construct a proper square face, the blue colored line is nothing but a required regular square face of dimension 100 millimeter. At an angle of 45 degree it will be there, where in case of isometric projection it will be reduced to 81.64 millimeter when the angle which is going to make will be always 30 degree. The angle between these two lines will be always 90 degree in case of normal projection, but whereas in case of isometric projection the angle between these two lines will be 60 degree. The same fashion angle between these two lines will be 120 degree. Now but here it will be 90 degree only, but here you can see it will be 90 degree only. Now you can see it is 90 degree only. Now how much a true length of 100 mm square will be reduced to isometric length? It will be 45 degree by 30 degree. Now we are solving it in the horizontal direction. Now we can apply the trigonometric values like cos. Now cos 45 degree will be reduced to cos 30 degree, that is cos 45 by cos 30 degree. In practical, how much it is going to reduce? Let us do the calculation. 45 degree of cos will be divided by 30 degree of cos. Now you can see the each and every true length will be reduced by 0.8164 times of true length. Now you can see the 100 mm line is going to be reduced for 81.64 in case of isometric projections. Now for each and every line it has to be reduced for 81.64. This is what an isometric projection of a cube of 100 millimeter. Now to draw these cubes and isometric projections, we have to follow some general guidelines. Which are the general guidelines? Now you can see the vertical edges remains vertical. What is the vertical edges? Now you can see the red color lines 1, 2, 3 are nothing but a vertical edges here. 1, 2 and 3. In the same fashion, the second point is called as horizontal edges, which are parallel to isometric axis or drawn at 30 degree to the horizontal. Now, which are those lines? Horizontal lines are nothing but 1, 2, 3, 4, 5 and 6. These 6 lines are horizontal lines which are drawn at 30 degree to the horizontal. Now you can see the angle which is going to make it as 30 degree. In the same fashion, the inclined edges which are not parallel to isometric axis should not be drawn at given inclinations. These inclined edges are drawn by first locating the endpoints in the isometric and then it should be joined. That is nothing but the inclined lines cannot be drawn at given inclination, which will be explained later while constructing the different types of inclined lines. Then all circles are represented by ellipses in case of isometric projections. Then the fifth point is nothing but the construction lines have to be retained as thin lines and the visible edges as thick lines in case of isometric. The sixth point is nothing but generally hidden lines need not to be shown in isometric unless otherwise required, either for locating a corner or an edge or a face or if mentioned. Unless otherwise specifically mentioned to draw isometric view or isometric drawing, all edges are reduced to isometric scale. What is isometric scale? Just now we have calculated, that is cos 45 by cos 30, which is 0.8164 times. And no need to indicate the dimensions unless it is mentioned. Now here you can see whatever the projections we are going to draw, we should need not to draw the dimensions like this. We should need to have only the isometric projection of a cube or whatever may be the given solid. Then view drawn with true scale is called as isometric view or isometric drawing. If isoscale is used, then it is called as isometric projection. What is isoscale? Isoscale is nothing but cos 45 by cos 30. That means 100 mm line will be reduced for 86.14. That is called as isometric projection. If this line will be drawn for 100 mm length at an angle 30 degree itself, then whatever the view we are going to get, that view we call it as isometric view or isometric projection. Then so isometric drawing, not the projection, sorry. But remember, isometric view or isometric drawing will be always 22.5% larger than the isometric projections. Now while drawing the isometric projections, we must and should remember these guidelines, and then we can solve any type of problems on isometric projections.